Hi there, this is Miss Townsend, and I love math. Welcome to Math with Townsend. This video is for grade 10 students who are working on their academic summative, and it's the solution to question 17. So let's look at it. Now question 17 is actually divided into A, B, and C, so we'll look at each part separately. It says sketch and then solve each triangle. And we're supposed to round our answers to the nearest tenth of a unit. So solving a triangle means find the values of all the angles and all the sides. So make sure that when you're done, you can label all 6 things fully. So let's look at this. So first of all, sketch. Now, I do a sketch in 2 steps. I always start kind of just with a really scribble sketch, and I never show my teacher this one because it ends up looking nothing like it should. I just draw like the fastest triangle I can. And this is just so I can get an idea about where my sides are. So I just drew a triangle, JKL. So this one's going to be 9.0, this one's going to be 5.2, and this one's going to be 73. And this is basically kind of just in my brain. So I'm just going to put my brain around it, my brain bubble. Hopefully you've heard me do brain bubbles before, otherwise that would be weird. And now I'm going to actually try to make a triangle that is sort of oriented like this, but has side lengths and angles that are more reasonable to these measurements that I was given. So I'm going to use a straight line tool. I presume you would use a ruler, but you certainly wouldn't be using a protractor. No one expects you to actually be measuring anything, but we do expect straight lines on our triangles. So here is a line that is 9 units long. Again, did I measure it? No, I'm just proclaiming that it's 9 units long. So now I need to make another line somewhere over here and try to make this angle look like 73 degrees approximately. So here's kind of the way that. This is 90 degrees. And so I need to be not that wide of an angle, but not too far in. So I need to, roughly go in a bit. There we go. That's 73 degrees. Now, how long does this side need to be? Well, if this is 9, 5.2 is a bit more than half. So just by eyeballing it and estimation, make this one a bit more than half the same length. Make sense? And then with my final line, just draw the third line of the triangle. And that's just to give me a better idea about what the triangle is going to look like. So again, this was just for me to get oriented. Where is J and K and which sides are which, etc. And now this is the one that I would submit and say, here's my sketch. So this was J, this was K, this was L, this is 9.0, this is 5.2, and this angle right here is 73 degrees. So how are we going to find the missing values? So obviously I'm missing angle K, angle L, and this side. And this side would be called side little j because it's opposite side big J. So let's keep going. This would be side little k because it's opposite big K. And this one would be side little l because it's opposite big L. So there's my triangle. Now I can't use any straight up trigonometric ratios because it's not a right angled triangle. So I can't just use sine, cosine, tangent. I don't have a hypotenuse. And if you don't have a hypotenuse, you don't have any hope of using the trig ratios. Therefore, I have to use either the sine law or the cosine law. Now, the sine law is only valid if I know one side and its opposite angle. So you'll notice here's side L, but I don't have its opposite angle. Here's side K, I don't have its opposite angle. And I don't know side J, so I can't use the sine law. Therefore, I have to use the cosine law. And since the angle that I know is angle J, then the cosine law will be about side J. So let's set that up. So J squared equals K squared plus L squared minus 2K L cosine J. So make sure you know how to set it up properly. This is the side that must correspond to the angle that you use. So I know this angle, so I have to solve for this side. The 2 variables involved are just the lengths of the other 2 sides of that triangle. So now that we've set it up, let's do the substitution and we'll do the math. So J squared equals K squared plus L squared minus 2 times K times L times the cosine of J. Please make sure your calculator is in degree mode. Okay, so J squared equals, so 81 plus 27.04 minus, and here I'm going to multiply these three things together. That gives me 93.6. And here I'm going to calculate cosine 73, 0.2924. So keep going, being good at math. So I can do this addition. 81 plus 27.04 is 108.04. Minus, multiply those together. I get 80. Nope, sorry, not yet. Looking ahead on my solutions here. I get 27.37. So J squared equals 80.67. And then square root both sides, I get J equals 8.98. Now I'm supposed to round to the nearest tenth, so therefore I would say that J is 9.0 meters in length. Now I'm going to go back to my diagram and make sure that that makes sense, right? Like my diagram, again, not perfect, but reasonable. And does 9 make reasonable sense for the length of this side? Yes, it does. So that's the length of J. And now that you have the length of J, we have to continue to solve for the triangle. So again, now I have J, it's 9.0. Now I need to find the K and L. And now, finally, I can use the sine law because I have an angle and I know the length of the opposite sides. So let's go to the next page and we'll set up the sine law. So I know that I have J and side J. So sine J over J must be sine K over little k, and also must be sine L over little l. So start with whichever pairing you want. Obviously, make sure that you use J because that's the one we know. So let's start here. So my angle was 73 degrees. J I just discovered was 9.0. The length of L is also 9.0. So do I really need to do a lot of math here? I don't think so, because if the denominators are both 9.0, then that means that sine L must equal sine 73, and therefore L must also be 73 degrees. So I didn't actually have to use the sine law. In fact, once I knew that this side here was basically the same length as this side here, I could have used the isosceles triangle theorem and stated that I knew, therefore, that this was also 73 degrees. Whatever. Okay, now, finding the length of K, you have two choices. Sorry, finding the angle K, two choices. One choice is to go back and use sine law again, but this time solving for K. Your other option is that you could use the 180 principle. So 73 plus 73 plus K must equal 180. So I'm going to use sine law just so that I can use the 180 principle as a nice check. So now I'm going to use this combination. So let me draw a line down my page here. And so this time I'm going to use K. So sine 73 over 9.0 equals sine K over 5.2. And now to do the math. Okay, so sine 73 is 0.9563 over 9.0 sine K over 5.2. So at this point, I'm cross multiplying. So 0.9563 times 5.2 gives me 4.9728. And 9.0 times sine k gives me 9.0 times sine k. So I'm trying to isolate sine k so that eventually I can isolate k. So that means I need to get rid of 9.0. So I'm going to divide both sides by 9.0. And what does that give me? So 4.9728 divided by 9. That's going to give me 0.5525 equals sine k. And now one more step to solve for k. So if I have sine k and I want to get rid of it, it means I need to do this. I need to do inverse sine because that's the opposite of sine. And if I do inverse sine over here, I have to do inverse sine on the other side of the equation. And that's just a button on your calculator that will let you finish the question. So here I'm left with k. And when I do inverse sine on that value, I get basically 34 degrees. And of course, I can do my check now. Hopefully you organize your work a little better. So is it true that 180 is 73 plus 73 plus 34? Is this a true statement? Do, 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 do. Yep. Therefore, I'm pretty happy with my math. Okay, so that was the solution to, let's go back. That was the solution to question 17a. And I think I'm going to do B and C in separate videos so that if you're only looking for the solution to one of them, you don't have to wait through the rest of the video. Okay, so I'll see you in the next part of this question.